All right, Joel Grus, Principal Engineer at the Capital Group. Welcome to the Data Exchange Podcast.
Hey, thanks for having me.
So, Joel, your background is actually in math and social science. At least
That is correct.
your academic degrees are in those areas. So, how did you end up in programming and software engineering?
It was a long and convoluted path. So once I left school, it was before the heyday of data science, let's say. And so I did what a lot of people with math degrees did back then, which was I got into quantitative finance. And I worked at a hedge fund doing options pricing,
Me
mathematics
too.
of financial risk, and so on. Um, things that I don't particularly enjoy, actually. And then the hedge fund went out of business actually pretty quickly. And just through sort of dumb luck and connections, I got hooked up with a startup called Faircast, which was doing, it was an online travel site that did price predictions for airfare. So you would say, I need to fly from Seattle to Los Angeles on these dates, and it would tell you the best price is 300, and we predict the price is going down, so you should wait and not buy today, or we predict the price is going up, so you should buy now. And so I got hired there in kind of a business intelligence type role. So what would probably be called like a data analyst today. Most of the job was either building spreadsheets or writing SQL. And I was there for quite a few years, actually, and it got acquired by Microsoft. And then around the time I left, data science was starting to become a thing. And this was like 2010, 2011. And I thought, I want to get into data science because it seems cool and it seems like it's a fit for someone with my skills. And back then, this will sound funny to people who are looking for data science jobs right now, but back then you could basically say, hey, I'm a data scientist, please hire me. And so my interview for my first actual data science job was the CEO of a startup who printed out a SQL query and showed it to me and asked me, hey, do you understand this? And I and I said yes, and he said, "Okay, good, you're hired." And that was what it took to get the job. And so at the time, you know, I was a pretty mediocre coder. I was an okay statistician, but still, most of my skills were SQL and Excel. But over my time, like actually being a data scientist, I took a lot of Coursera courses. I started learning a lot more about Python and coding and computer science. And I worked at a company called Volumetrics where the product was actually kind of a data science type product. And so what that meant was that even though as a data scientist, I was writing a lot of I was writing a lot of production code, like code that ended up being shipped to customers. And it was really bad production code. Like it's embarrassing that in some ways that this code was shipped to customers. But I discovered that I actually enjoyed that part of my job. And so I thought, you know what, I would like to build out this part of my skill set as well. And through a somewhat comical process, I had the opportunity to interview at Google for a software engineer job. And I spent about 6 weeks just cramming as much computer science as I could into my head. And somehow I made it past the interview, and then I was a software engineer. And so I spent a couple years doing that. And, you know, I went to Google in part because I wanted to learn how to do software engineering really well. And I think it worked for that, but I wasn't enjoying the sort of problems I was working on there, which were kind of boring. And so I left and joined the Allen Institute for Artificial Intelligence, where I had a role that was more kind of at the intersection of software engineering and data science. I was called a research engineer, and basically my job was to build deep learning tools for NLP researchers. So basically I had to speak the language of software engineering, also had to speak the language of NLP research and kind of be able to bridge that gap, which is kind of that's the role in which I'm kind of happiest. So I was at AI2 for about 3.5 years. I left last fall to join Capital Group, and now I lead a team that implements machine learning and data solutions, kind of along the same lines. It's kind of really at the intersection of software engineering and data science. And then, you know, along the way, back in like 2013, 2014, I saw all these data scientists, you know, getting famous on Twitter or wherever, and I thought I want to be a famous data scientist like these people. So I ended up writing a book for O'Reilly called Data Science from Scratch, which is my big data science claim to fame, and second edition came out last year. So
Yeah. Actually, a lot of wonderful details in your journey there. For the youngsters who are not that familiar with Faircast, I would say Faircast was actually one of these initial success stories of the use of data and predictive analytics among, I mean, at least there were a lot of articles written about it, right?
It was a success story in the sense that there were articles written about it. It's also a success story in that it was acquired by Microsoft and became Bing Travel and sort of trucked along for a few years before they shut it down. It was interesting. It's funny to look back because all of the tooling that we take for granted now just didn't exist then, right? And so the way that they trained machine learning models was using their own like homegrown C++ library that their lead data miner wrote, and then they had a Sun grid engine on which they ran these distributed compute jobs. This was pre-AWS, pre-TensorFlow, I don't think it was pre-scikit-learn, but it was pre a lot of these things. And so just, and it was funny, not funny, funny/sad. Right after the company was acquired by Microsoft, the site went down because the data center where it was hosted caught on fire. And so basically the ops team and all the engineers had to go camp out there and like bring generators and like hand take care of these servers in a way that you can't imagine having to do at a startup these days.
So speaking of your first book, Data Science from Scratch, was a hit. As I remember, I mean, I think I was still managing some of the editors working on that book at that time. Although I'm not an editor myself, I don't know actually why O'Reilly wanted me to manage editors. I have no idea. But anyway, there's actually, I don't know, Joel, if you were familiar, before your book, there was another book which was not the same, but kind of the same kind of vein, which was called Programming Collective Intelligence. Did you ever?
I think I have that book on my shelf somewhere. Yeah.
Yeah. Did you ever read that book? So when your book came out, it was like kind of that book, but a lot more.
Yeah, if I remember correctly, that book was based on more using libraries. Is that right?
He was also, I think, at least for some of the simpler models, I think he tried to implement it himself. But your book definitely took it to another level, right? So.
Yeah. So if you're not familiar with the book, the premise of the book, the from scratch part, is based on my belief that the way to understand things and to learn them is by really like taking them down to the barest details. So rather than using NumPy in the book, we actually use Python lists as arrays. And rather than using scikit-learn, we actually implement our own decision tree algorithms. We implement our own linear regression model. We implement our own neural networks. And so these are kind of not practical implementations, but they're illustrative and they help you understand what these models are actually doing.
So I imagine that book has been translated, right?
Many times, yeah.
Yeah. So you hear from readers from all over the world.
Yeah, there's a Chinese version, a Korean version, a Russian version, a German version, a Portuguese version, which I guess is mostly from Brazil. It's funny, the Portuguese title is Data Science Do Zero, so it makes it sound like you don't want to do any work. But yeah, it's been translated. And then the second edition came out last year, so now there's a new set of translations based on that. It's funny, actually, in the first edition, there was an extremely subtle bug in the book, and as far as I know, the only person who ever found it was the Chinese translator. And no one else has ever, like, I didn't know about the bug. No one else has ever mentioned it to me, but the Chinese translator, like, he was like, yeah, I think this is a bug. I was like, wow, do you get a prize? Because no one else has ever like gotten into that level of detail.
And then actually, so the other interesting thing that you've worked on recently, of course, is AllenNLP, which is also now a popular library among researchers. And then after AllenNLP, you wrote this book, or maybe during while you were still at Allen AI. But describe for us the thesis and genesis of this new book, FizzBuzz.
Yeah, so in 2016, I wrote a blog post called Fizz Buzz and TensorFlow, and it was basically a dialogue.
Went viral, right?
It went viral, right? It was a dialogue between a candidate and an interviewer, and the interviewer asked candidates to solve FizzBuzz, which is like a very elementary programming problem that has a reputation as this is, you know, the lowest common denominator question you can ask someone. But basically the problem is, for print the numbers 1 to 100, except if the number is divisible by 3, print Fizz. If it's divisible by 5, print Buzz. If it's divisible by 15, print FizzBuzz. And so and so the blog post was an interview where you know, someone was asked this in a job interview and was insulted, and so decided to solve it as a deep learning problem, like just to kind of be a jerk to the interviewer. And so, like you said, that post actually went pretty viral. It came to the attention of Jeff Dean, which is something that never happened to me when I was actually working at Google. It took leaving and writing a blog post to get Jeff Dean's attention. And you know, Peter Norvig emailed me about it and things like that. So like it went pretty wide. And you know, because of that, some people associate me with that problem, FizzBuzz. And so just as sort of a random hobby, I've started since then collecting random other interesting solutions to that problem. It turns out there's a lot of interesting ways to solve that problem. And then about a year ago, someone on Twitter was like, you should write a book on 100 different ways to solve FizzBuzz. And I thought, you know what, like 100 is a lot, and I don't think I can come up with 100 interesting ways, but I bet I could come up with 10 interesting ways. And so I sat down and tried to come up with what are 10 interesting ways to solve FizzBuzz. And then what I did was I took each one and made a little essay out of it and said, here's a solution. And now I'm just going to talk and maybe ramble a bit about here's why this solution works. Here's some other things in Python that are related to this solution, or in programming that are related to this solution, that you should know, and so that I'm going to tell you about. And so there's a lot of, you know, there's some interesting digressions about mathematics, about how to test software, about common Python mistakes, about how to model data in Python. Like there's a lot in there, and kind of, I say in the introduction, basically, this is a book that you'll learn a lot by reading, but it's not a book that you would read to learn anything in particular, which puts it in sort of a weird spot, because there's no one out there thinking, I really need to learn a lot about FizzBuzz. But and that's my challenge as a marketer and salesperson.
But you know, I mean, I started reading the book, and I have to say, I mean, actually, there's a lot of little nuggets in there that if you want to really improve your Python programming skills, there's a lot of tips that you impart as you're describing how to solve FizzBuzz in a specific way, which I think that I encourage people to get this book, even if you consider yourself somewhat of a experienced Python programmer. I believe there's still a lot of things in there that you'll pick up and put in your arsenal and
yeah, well, I'm a very opinionated Python programmer, and so it's imbued with my opinion. So even if you know a lot about Python, you may not know a lot about my opinions on Python.
So speaking of which, Joe, so have you cast around at all in terms of programming languages, or you're pretty much Python is what you use, and you don't program in other languages?
I would say these days, almost everything I do is in Python, because I've written so much Python and I'm so comfortable in it that it's the easiest for me to use and think about by far. When I was at AI2, you know, when I worked on AllenNLP was a Python library, obviously, so that was Python. I also did, let's say, 15% of the time React, like building little web apps, and so I'm not a front-end developer, but I know a fair amount of JavaScript and a fair amount of React for someone who's not a front-end developer. When I joined AI2, actually, and this is sort of interesting too, but when I joined AI2 in 2016, it was completely a Scala shop. And why is that? That's because NLP, which most of the projects there were, had not gotten that into deep learning yet. And so a lot of the work that was being done was really oriented around like Stanford Core NLP, which is a Java library. And so everything being done was done in Scala. So the first year or so I was at AI2, I did a bunch of Scala. At Google, I mostly did C++ while I was there. I was there a couple of years. And then at Volumetrics, which was the startup I was at before, the data science-y parts were in Python, but the actual like application and production code itself was in F#, which is actually a neat language that's less popular than it should be. So And then recreationally, like I've always dreamed of being like a Haskell programmer, but I've only ever kind of dabbled in it. So that's a long-winded way of saying I have used a lot of languages, but these days I mostly use Python.
So you, Joel, personally, as you were writing this book, Fizz Buzz, obviously you had to. It's different when you're hacking, and it's different when you're writing code to teach someone and to nail it down in a book. So you must also personally have learned a lot of things, right? Writing this book.
Yeah, so that's actually a skill that I honed writing data science from scratch, and especially the second edition. So the first edition of Data Science from Scratch, which came out in 2015, was in Python 2.7. And as time went on, two things happened. One, I started to feel really guilty that there was a book out there with my name on it that told people to use Python 2.7. And the second is I kind of grew as a programmer and a teacher, and sort of came to realize that a lot of the code that I'd written in that book, I didn't like the way it was written, and I didn't think it was written in a way that really explained things very well. So I went back to O'Reilly in 2018, I guess, and said, I'd really like to do a second edition. Here's why. And they said, fine. And when I went through that second edition, in addition to updating all the code to Python 3, I really approached every line of code with a fresh eye, asking the following question. I am using this code because I'm trying to explain something to someone. So, maybe this is a function that's showing what a dot product is, or maybe this is a function that's showing how does gradient descent work. And I really stopped and asked myself, okay, given that I'm using this code to demonstrate this, let's be really thoughtful about how we choose variable names, which Python idioms we use, how we write out the algorithms, how we break things into helper functions. And there's a way of writing code where obviously your code has to do the right thing, but you can write code with a real eye towards, I'm mostly writing this in order to demonstrate something and to teach and to make it readable above all other considerations. And so that's a skill that I think developed writing the second edition of data science from scratch. And I think it's really spilled over, and now I tend to write Python that way anyway, even if I'm just doing random things. But definitely I use that in the FizzBuzz book.
So let's segue a little bit into data science and machine learning tools. So you're the person who wrote data science from scratch, but obviously people are not going to be doing data science from scratch at work, right? So they're going to use libraries like scikit-learn or Spacy or something, right?
Yep.
Stats model and stuff. So first of all, so describe on a day-to-day basis what are your go-to tools these days?
WebEx.
AllenNLP.
No, I was going to say WebEx. That's been half a day in meetings. But no, with the things that I'm building right now. So Capital Group is a big old company that invests and has mutual funds, and it has this premise of we're doing long-term research-driven fundamental investing. And so my job as a machine learning person at a company like that is, how can I build tools to, help people produce research, consume research, basically not to replace the humans who are doing this research and really trying to deeply understand these companies and these industries, but how can I build tools to make them more effective? And so what that means is that I'm doing a lot of, one, I'm doing a lot of NLP, but two, I'm doing a lot of really early prototypes. And so for the early prototypes, I tend to use Spacy. It's just very simple to get started and very simple to roll out these quick, either text classification or entity recognition or any of those models. And we've been using it in conjunction with Prodigy, which is a text annotation tool made by the people who make Spacy, and it allows you to do model in the loop training. So we've had some good success with that. I think that at some point I'm probably going to need models that are a little bit more sophisticated, and then probably my go-to is going to be the Hugging Face Transformers library, which I'm a big fan of. I'm also like, I love AllenNLP. I built a big chunk of it. I wrote a lot of the code in it, but for the sorts of problems that I'm solving now, it's overkill for those. And I think if I were really doing, more researchy problems, then I would probably be using it. But since I'm just kind of building prototypes and throwing them against the wall and see what sticks, it's not the right tool for me yet.
So what are you using, Joel, for data processing, or if you need to use deep learning? So for those two pieces, what are you using these days?
So for deep learning, I use PyTorch. I'm a PyTorch person.
Yep.
Even though the blog post was FizzBuzz and TensorFlow, that blog post was kind of the only TensorFlow I ever wrote in my life, approximately. And so it's funny. AllenNLP as a team spun up in, I think, 2017, and I joined right around when they started. And I went on vacation when I finished up with my previous team, which was Aristo, and I went away for a week. And when I left for vacation, AllenNLP was going to be built on top of TensorFlow. And I went on vacation for a week, and I came back and said, "Oh, by the way, we're building on top of PyTorch now." So since then, I've basically been doing PyTorch nonstop, and it's what I'm comfortable with. I like the library, and so that's what I use. What was the other part of the question?
The other part is data processing. So true or false? 80% of a data scientist's job is spent cleaning and wrangling data.
I'm not really a data scientist anymore, but I would say it depends, right? Like I'm willing to, if you train one model per data set and then move on to the next data set, then maybe that's true. If you have a data set that you're really investing in cleaning once, and then you're going to take that data set which has been cleaned and try and do a bunch of different things with it, then it's probably not 80%. It's probably a much lower number.
So you don't do much of data engineering, data processing these days?
I do, but it's for the most part these days I'm working with a small number of data sets. So the data engineering and pre-processing it's a lot of work, but it's mostly one-time work. And once it's done, then the pipeline's there and it does what we need, and then I don't have to clean it again.
So you've done a few things that have gone viral. So the other thing that I wanted to ask you about is your famous talk at the first Jupytercon, which is the opposite of love Jupyter notebooks. So
it was actually just I don't like. People characterize it as hate. I was very careful not to say hate. I said I don't like.
So that was maybe 2018. So has your thinking changed, or?
No, my thinking has not changed.
By the way, before you answer that question, thank you for telling me about Streamlit, because now that's my combination is Visual Studio and then Streamlit. But anyway, yep, so notebooks.
It's a good combination. So here's what happened, which was, as I mentioned before, when I joined AI2, AI2 was a Scala shop. And then when we started getting into deep learning, everyone sort of had to switch to Python. And what happened is there were a number of pretty senior people at AI2 who they were senior as software people, but they had never used Python. So they had to learn Python. And so I said I would help them. And so one of them came to me one day, and very, very smart engineer, and she was super confused. And she's like, Python makes no sense to me. I don't get what's going wrong. Like, what am I doing wrong? And she was using a notebook, and she had run the cells out of order. And because she'd run the cells out of order, the hidden state had gotten all messed up. And so her mental model of what variables were equal to was wrong, and so the code wasn't doing what. So like the classic Jupyter beginner mistake, basically, or expert mistake, because I talk to people like, I've been using Jupyter for 5 years, and just this morning I wasted an hour because I ran my cells out of order. So anyway, she came to me with this, and I was angry, and I was angry because I said, why did you use a notebook? She said, oh, well, someone said that was a good way to get started. And that was basically the only reason. And the notebook was really what confused her, not the Python. And so I went out and I tweeted and I said, I was angry. And most of the time you shouldn't tweet while you're angry, but this one time it worked out okay for me. And I said, if anyone wants me to give a talk on why Jupyter notebooks are bad and you shouldn't use them, let me know, because I would love an excuse to write it. And then one of the Jupytercon people saw it and they're like, we won't make any promises. And so one, like a lot of people got mad at me. Jeremy Howard got mad at me. Jake Vanderplas, he doesn't really get mad, but he disagreed with me. And so a lot of people like really pushed back on me a lot. But the Jupytercon folks said, propose it. So I proposed it and they accepted it. And then I thought, you know what, like, I don't actually know that much about Jupyter notebooks. I just know that I was angry once and I tweeted about them. And now I'm going to go into Jupytercon and give a talk about how I don't like them to an audience of people who probably love them. Like, I better figure this out and like understand, what are my complaints. So I spent more time on that talk than I've ever spent on a talk. Like,
great talk.
I started it 6 months in advance, I would say. Usually you start a talk maybe a month in advance, maybe a couple weeks in advance. I started that 6 months in advance. I basically had that Google Slides window open in my browser constantly for 6 months, and I kept putting ideas in it. I kept exploring and like trying to come up with like, what are my complaints about this tool? And I put it together, and the talk turned out well. It had a lot of jokes in it, but it was interesting because I did not expect that talk to go viral. Here's what I had expected, like 100% truly. I expected I was going to go to the conference, I was going to give the talk, people in the room would get mad at me, and then we'd like all go home and forget about it. But it turned out that there are a lot of people who didn't like notebooks, but never said anything because they thought they were the only one. And now suddenly you have this talk, which is kind of like this Schelling point of, notebook dislike, and all these people came out of the woodwork. And I suspect the Jupyter people were a little bit taken aback by that. I know I would have been. And so, last year I went to iClear, which is a academic deep learning conference, and I was part of a workshop on. So one of the complaints in the talk was that notebooks actually make reproducible science harder, and I have some reasons for thinking that I won't go into right now. But anyway, because of that part of the talk, I kind of got invited to a couple conferences to speak about reproducibility and tooling. And so at iClear there was this reproducibility and machine learning workshop that I went to, and I was on a panel there, and there's a woman on the panel from Project Jupyter who I'd never met before. And so I went up to her before the talk, and I said, or before the panel, and I said, "Hi, I'm Joel." And she looks at me and she goes, "I know who you are." So,
by the way, as someone who has chaired and organized many conferences, so there typically in these conferences there are tutorials that last 3 hours, right? So there's, in my mind, I don't know how you feel, Joel, there's not much you can really teach in depth in 3 hours, especially if you're expecting people to do some coding exercises. So actually one of the things in your talk that kind of resonated with me is you go then to these tutorials, the instructor has the notebook, and then it's just basically you're just pressing buttons the whole tutorial, right? So I mean, maybe at some point there'll be a part of the tutorial where there's an exercise where you have to solve it, but it's
so here's the sad joke, which is that I gave an AllenNLP tutorial at the last O'Reilly AI conference, right? In San Jose. And so I went to a lot of work I investigated Binder and all these tools. And so I set up this like Binder hub where people could clone my code and they would get their own little notebook. Like notebook seemed like the best solution to this problem. Each person would get their own instance, and I very carefully set up, we're going to like code along with each other in this tutorial, and you can use your own Binder instance and so on. And then it turned out that no one in the room wanted to do the coding. They just wanted to watch me like code. So it wasn't it wasn't shift enter all the way down, because I actually had to type out the code and solve the problems, but it was them kind of just watching me compute. So
right.
History rhymes.
But I don't know. I think the reality is, and my sense is that people probably use notebooks, but they're not using it for in the expectation that this is how I'm gonna productionize anything, right? So,
Um,
is that true? I mean, maybe I'm just being
it,
naive here.
it depends. I mean, it's at some places that's definitely true. At some places, like for instance, Netflix, they have like all these production pipelines that are designed around notebooks, and notebooks are kind of an integral part of those pipelines. But um, but I think you get at an interesting point, which is that historically, a lot of data scientists will just say, I'm doing a prototype. It's not my job to productionize this, so I'm not going to, worry about those aspects of it. And this is, this is one of my, I have a lot of pet causes, obviously. This is one of my top pet causes, which is basically why data scientists should care about software engineering best practices, or depending on the audience, it might be why researchers should care about software engineering best practices. But basically, I think that data scientists and researchers should really be much more concerned with these topics. Everything from testing my code, doing code reviews, like having high standards for the code quality I produce and continuous integration, things like that, to thinking about how is this actually going to go into production. And in fact, if you go back to 2014 when I joined Google, so that was actually 6 years ago, one of the reasons, so I said I enjoyed writing production code and I wanted to get more into software engineering. I also looked at the world around me and made the judgment, and so far I don't think I've been right about this, but anyway, I made the judgment that in the future, the data scientist who can't really write code is not going to be that valuable, and the data scientist who can also write code is going to be valuable. And I don't know that the world has actually played out that way, but certainly I think I've enjoyed my career more by sort of turning in that direction. So
I think that so I agree with you, but I think that maybe the job title for the person who's writing code is now ML engineer, and then data scientist still is kind of in this early before production, unfortunately, and then I don't know. So maybe as some of these techniques mature and you can rely on libraries, then maybe engineers can do a little bit more because they're more flexible. Like you said, they can code, they can touch production systems. Whereas data scientists are kind of over here doing prototypes.
it's funny that the title machine learning engineer has never resonated with me that much either. And I'll tell you why. And I've never had a job that was called ML engineer, but I think of an ML engineer as being someone who maybe knows how to put ML models into production and things like that, and maybe knows how to program them.
But
And
a little bit, know some ML. Also know some
no,
ML.
some ML,
Yeah, yeah.
but I guess the way I think of my job, and in particular the way I like to think of people on my team, is that MLE is like a third of what they do, and then like traditional data science is like a third of what they do, and then traditional software engineering that maybe has nothing to do with ML or data is also a third of what they do. And so maybe that's like a unicorn. I think of the job in my head as like what I call a data science engineer, but like not yesterday, but a couple of days ago, I was like mucking with Apache and Apache config files and things like that, right? So things that have nothing to do with machine learning, but that are more pure engineering tasks that I need to do to get my job done. And I personally am not happy when I feel limited to one of those three things, and so I try and end up in situations where my work spans everything.
That's why it's ML engineer, man. There's ML and there's engineer.
Right.
So speaking of which, so you wrote data science from scratch, and then FizzBuzz. There might be another. So let me pitch you on another from scratch book that you might consider.
Okay.
It seems to me that now, as you know, the last few years there are a lot of exciting things happening in NLP, right? So
Yep.
with transformers, these big language models, but a lot of people are not really, it's a bit opaque to most people, right? So they just call Hugging Face and and that's that. They don't know exactly what's happening with these models, or even how to do tuning and transfer learning, right? So you
Yep.
take one of these models, it may not work exactly with your data, and then you'd have to tune it. So it seems to me there's an opportunity to help people kind of learn a little bit more of the details, but even short of that, just learning how to take some of these libraries and make it work for their domain and data and setting. What do you think?
I mean, there's definitely room for that. There's a lot of blog posts on those topics, and a lot of them are not very good. So I
And
can
also, they're not
appreciate
collected.
that.
They're not collected into one centralized,
Yeah.
curated, organized way, right?
So here's the other tricky thing, which is that anytime you write a book about libraries like that, it's going to go out of date very quickly, right?
Yeah.
And so secretly, like, one of the reasons why the From Data Science from Scratch appealed to me is that it's a much more evergreen book than a book that would be like, inside PyTorch 1.4 or something, right? Because the reality is that other than the Python 2 to Python 3 switch, a chapter about linear regression today using list as your vectors is not going to be particularly different from what that chapter would have looked like 5 years ago, and it's not going to look super different. Whereas a book like, let's say I write a book about Hugging Face or whatever, then Hugging Face changes their API and the whole book is out of date. So that makes it.
They're quite adamant that their API is stable. So let's assume that, right?
Okay.
So, but then to most data scientists, it's still a black box, right?
So I guess here's the other thing. So people talk a lot about imposter syndrome in our industry, right?
Yep.
And by and large, I would say I don't tend to suffer from imposter syndrome, at least among the things I do for my job. I'm pretty good at them. But when it comes to NLP, I am a little bit of an imposter.
You wrote AllenNLP, man.
I know, exactly. But so here's the comical thing is that before I joined AI2 in 2016, I had done very, 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 very little NLP in my life. Like I took a Coursera NLP course, and there was a really basic NLP chapter in Data Science from Scratch version 1, but that was about it. And then what happened, interestingly, was that NLP went through this really seismic shift right around 2016, where suddenly it was all LSTMs and transformers and BERT. And so I started doing it right when it changed. And so because of that, even though I was like really kind of new to the space, I had as much experience with LSTMs and BERT as lots of people who'd been doing NLP for 10, 15 years, because they started doing BERT and LSTMs at the same time I did. And so because of that, like I managed to sort of keep up with them on some grounds, but probably not others. And so I'd be in these situations where I'd be talking with researchers, and they'd be like, "Here's what I want to do," and I would, suggest, "Oh, have you tried, modeling it this way and using this kind of model and doing this kind of." But behind the scenes, I'm thinking, gosh, this is a person who has a PhD in computer science and has been doing this stuff forever, and I've been like working on this AllenNLP library for like 2 years, and like, why are they listening to me? All that's to say is that the few times that I've tried, so I've given some talks about like, here's actually an overview of NLP as a discipline, and every time I wanted to do that, I had to like lean really heavily on actual NLP experts, and be like, okay, here's my caricature of the history of NLP. Tell me everything in it that's completely wrong, and like help me fix it so that I don't sound like an ass when I get up on stage. And so
actually, Joel, as you're talking there, it reminds me of some conversations I've had with people in computer vision, right? So these are some of the more old-timer people who preceded deep learning, and of course now deep learning dominates computer vision, right? And to some extent, actually, you don't actually the old techniques in computer vision that you had to learn, you may not need anymore because you just use some deep learning thing, right? So in NLP, are we getting to the point where some of the old school NLP people lament the fact that which reminds me, actually, I had a conversation with someone who's in grad school for NLP, and this is still a grad student, and this grad student is lamenting that the first year grad students don't even know what TF-IDF is, right? So.
Right. I do know what TF-IDF is, but basically, so I'm in a spot where, and this is what my job is. If you said to me, "Here's a business problem, I'd like to use NLP to solve that," I think I know that kind of stuff like really well, and so I get that. But if you say to me, I want to one talk about like the grand history of NLP and tell a story that ends up at Transformers. That's a little bit more outside my wheelhouse. And then also, since I left AI2, I haven't been paying as close attention to the space. And so, if you ask me what's new in the world of Transformers, like I don't know because I haven't been paying them. But anyway, I think your book is a good idea. I think you should pitch it to Hugging Face. I think someone who works at Hugging Face should probably write that book. They do a better job than I would.
But so I guess to my question, like as you point out, right? So you entered this field at the right time, NLP. You started working on it, and now you're kind of caught up. And I mean, up until the point when you left AllenNLP, right? So you didn't have the history of 10 years of what they were doing before, but then you could probably be as productive solving some of the problems. Is that true?
Yes and no, right? Like what I can say is that I am familiar with things like here are the key data sets that people use, or here are the problems that people look at in the field, or here is the state of the art. But I'm not as familiar with, okay, before BERT, like what are all the different things people tried for text classification? The same way if you asked, I'm not a computer vision person, but I went to a talk before I left AI2. There's basically how did computer vision work before deep learning, and like everything at that talk was like I never heard of any of this stuff. So there's a lot there that's just like I don't know about. And in NLP, there's other stuff too, like some of the ways that. And the other thing is that for things that are so uniform, like let's take BERT or Roberta and stick a classification layer on the end of it. Okay, I get that. But now I want to use it to solve some sort of like parsing problem. Then you got to know a lot about like how does parsing work and what is the history of parsing. And those are things that I just don't know that well.
All right, so let's shift gears here and talk a little bit about to talk a little bit about engineering, management, and maybe a little bit about hiring. So first question, since you're now a manager, should engineering managers code?
So I would say yes. I'm in a little bit of a weird position in which I'm barely an engineering manager. And so what do I mean by that? I mean that I was actually hired as an IC. So my title is principal engineer. And through some maneuvering, I managed to get my hands on someone to work for me. So I have one person who reports to me right now, and he's a godsend because he's like having an extra set of hands, basically. But as someone who manages literally one person, of course I should code because otherwise, what am I doing? But I have peers who are engineering VPs who manage organizations of 20 or more people. And should they code? I think it's up to them. Like, I have trouble imagining me being happy at a job if I wasn't coding. And when I worked at Faircast, the VP of engineering, who was the most senior engineer there, he wasn't coding anything, let's say, mission critical or that was on the product roadmap, but he was coding like, hey, I'm going to try building an iPhone app just to see what happens and things like that. So like he wanted to stay in the game, but not make himself, a dependency. So I personally think that engineering managers should code as long as they can. And at some point it may make sense for them not to do it anymore. The thing is that I like coding and I also like managing people. And so I want to do both.
So some people say if you're still coding, maybe you didn't do as good a job putting together your team, or you're working on things that are cool and someone else should be working on the cool things. The exception being maybe you should still write tests, right?
Okay, so I agree with you. if someone would wave a magic wand and say, you know what, Joel, you can have as many headcounts as you want, and in exchange, you can't code anymore. You can only like tell people what to do. I might take that trade-off, but until someone gives me as many headcounts as I want without limit, then like I have to code. Otherwise, I won't get done the things I need to get done.
So what?
But I do agree with one thing you said, which is that I think a good manager, like I think it's a bad manager who like hogs all the interesting, problems for himself and parcels out all the boring problems to other people. I, I think to the extent possible, the manager probably should try and do the boring problems himself. And obviously there's like sometimes only one person can do something best or whatever. But I agree that if you're keeping all the interesting problems for yourself, that you're doing your people a disservice.
So so to close, let's talk a little bit about hiring data scientists and engineers. So
Yep.
if you had a magic wand, how would you change this whole hiring process of interviews, maybe having people? By the way, I just read a study which showed that companies might be leaving a lot of good candidates on the table because they insist on having people go up to a whiteboard and solve some coding problem, and some people just freeze when they're asked to do that, right? So that doesn't mean they're bad engineers. So what are the things in hiring that you would want to see changed?
So I think I saw the same article that you did. I tend to put less credence in those things, and part of the reason is that so my wife is a management consultant. She went to MBA school, and then after that, she got a job at Deloitte. And so, how do you become a management consultant? Well, they do these case interviews where you walk in and they say, okay, they put you in a room and they say, you know, so and so owns a small craft brewery and is thinking about expanding to, servicing supermarkets and distributors. Like how, and basically they ask a lot of questions, and you have to like frame it out as a business case, and you have to ask the right questions. So it's this very like contrived interview format, and there are books like Cracking the Case Study on how to do well in this format. And MBA students all like practice these things to get good at them so they can do well in their interviews. So there's a lot of ways in which these case interviews are sort of analogous to coding interviews. But what you don't see is these MBA consultant types saying, gosh, some people are just bad at case studies, therefore this interview is unfair to them. They say, hey, you might be bad at case studies, so go out and like freaking practice, right? You know that this is how we hire people in management consulting, so like get the book, go practice. And so that's a little bit how I feel about this whiteboard objection, which yes, like some people are not good at, may not be good out of the box at coding on a whiteboard versus in an IDE. At the same time, I feel pretty confident that that's something that you can practice and get better at. Like it's very hard for me to imagine that it's something intrinsic to your nature or to your makeup that, you know what, I am incapable of coding on whiteboards no matter how much I try. And so, some of that I just feel like is, I'm not good at that, therefore, and I don't want to get better at it. So at the same time, I think
By
a
the way,
lot
the
of
whiteboard is out right now because of COVID anyway, right? So
right. So, true. And side note, when I was at AI2, I um, I pushed HR and I said, hey, could we do CoderPad as an alternative to whiteboard coding for onsite? So we put a laptop in the room and we offer people the choice. Hey, you can either code on the whiteboard or you can code in this little like IDE, whatever you're more comfortable with. I'm cool either way. You pick what works best for you. And I found two things. One is that not a lot of people chose the computer. Most people chose the whiteboard anyway. The second thing, and this was actually more surprising to me, was that the whiteboard interviews went better. Why did the whiteboard interviews go better? They went better because once you're coding in an actual IDE, you get very concerned that your code actually compiles and runs. And so things like missing parentheses or minor typos or syntax errors like that, things that on the whiteboard as an interviewer I would ignore or I wouldn't even notice, they would derail these CoderPad interviews because sometimes it would be like a really subtle missing parentheses, and like as the interviewer I couldn't find the unbalanced parentheses either, and it would take us 10 minutes together to like, and so what I found was that there's a big trade-off either way, and one of the virtues of coding on the whiteboard is that you sort of free yourself of having to get into these, like, obviously if you don't know how to write a for loop, that's a big issue, but if you put one too many parentheses somewhere, like, I'm not going to ding you for that in an interview. Like, I do that all the time. And so what I found was that the CoderPad actually, as an alternative to the whiteboarding, did not result in a better experience. Okay, so that's my digression. Now, what I was going to say is I think a lot of the questions that we ask in these whiteboarding interviews are really bad questions. And so there's a whole class of questions that have the flavor, basically, here is some kind of problem. So the canonical one is like, here's a list of numbers. Tell me if any two of them add up to a third. Tell me if any three of them satisfy a plus b equals c, where I think that's it, or maybe it's with a squared plus b squared equals c squared, where there's kind of an obvious quadratic solution and a not obvious linear solution, and then the question is, can you find the linear solution? So I hate those questions as interview questions because they're testing things like, have you taken an algorithms class recently, or are you like really clever so that you can figure this out? And I don't think that's what you're going to be checking for in an interview. What I want to be checking for in an interview is, here is a description of an algorithm. Can you turn this algorithm into code in sort of a clean, like readable, idiomatic way that demonstrates to me that you can think algorithmically using code? And so I have a couple of questions I ask along these lines, and I've had people get really hung up. They're like, is this a trick question? I'm like, I promise, like, it's not a trick question. I've told you what I want. Like, I want you to turn this algorithm into code. Like, that's all I want. There's no tricks. Like, and so that's the coding questions I like to ask. So like, I can give you an example because it's not a question I ask, but it's the flavor of things I like to ask. Is you're familiar with Sudoku, right?
Yeah. Yep.
So Sudoku. So imagine the problem of I'm going to give you a filled-in Sudoku board. You tell me if it's a valid solution. Okay. There's nothing magical to that problem, right? It's really just, here are a bunch of conditions that I want to know if this meets, and then I see, how do you approach that as a software engineering, coding problem? And I think seeing how someone solves something like that, problems of that flavor, I think can tell you a lot about them as a coder.
So what would be like a canonical question that you would ask for a data science interview?
Honestly, I haven't done, I've done like one data science interview in the past 5 years, maybe two. So what would I ask? For a data scientist, again, I would probably ask, I would make them code because I expect data scientists can code. But what I might also ask are things like, if it's a person who's done machine learning, I would say, pick a machine learning algorithm that you think you know pretty well, and like explain to me how it works. So I don't want to gotcha them with like, okay, explain to me how support vector machines work. Maybe they don't know that, or maybe they're rusty. But like, put the ball in their court. Pick an algorithm that you like whatever. Teach it to me, and like, show me how it works, and tell me what I should know about it. Things like that. That I think gives them a chance to show me what they know, but also gives them the autonomy to be in a space or in a part of the modeling world that they're most comfortable with. I think things like that can really get, and then I can drill in and say, okay, what about hopefully it's hopefully it's not some algorithm I've never heard of, and I'll know some things about it, and I can push on them and see like how deeply do they understand this, and do they know when it's applicable, when it's not applicable, do they know the pros and cons, things like that. So but for data science beyond the coding, I want to understand what do they know, but for the most part I don't want it to be do they know this thing I think they should know. It's can they demonstrate to me that they know their stuff in the way that they're comfortable with. Does that make sense?
Yes. Yeah. And with that, Joel Grus, thank you for the earlier book, Data Science from Scratch, but also thank you for this new book, which I highly recommend to
can I plug all my various like addresses and
sure,
names and everything?
Yeah. Go ahead.
Okay, so if you want to check out the FizzBuzz book, you can just go to fizzbuzzbook.com, and that will take you to the book's site. You can find me on Twitter at Joel Grus. That's my name, JoelGrus. I have a blog that I very rarely update at joelgrus.com, and then Data Science from Scratch. You can just it actually doesn't have, I should set up a website for it, but you can Google it. It's and then don't buy one of the counterfeit imposter ones that they sell on Amazon. Buy the one that's by me.
Thank you.
All right. Thanks, Ben.